welcome to this basic data pre-processing tutorial. Now, data pre-processing has few parts in it. So we would first focus on the first part, and then we would go on the next few parts. Now, first of all, what is data pre-processing? So for regression, for machine learning models, for making them, for using the data for that, you need to train the models, and for that you need the data. Now, before the data directly goes into the training set, we would first need to take some precautions so that the accuracy of the models is not compromised. Now, what is those few steps? Okay, so those few steps are nothing but the data pre-processing. We need to clear out some defects in our model, or some missing values in our model. We need to first clear out. We need to first filter out all those models for all those defects before actually using it in our training set. So that is data pre-processing. Now, in the first part, we would look at imputer. Now, what is imputer? Whenever in the data we go for the data set, we find some missing values. So that's what imputer does. That those missing values should be filled out immediately. So imputer class is already an inbuilt class in Python, so we can use that class to fill that missing values so that the accuracy of the training model is not compromised. And that's the first part of data pre-processing. So we would first import the basic library. Sorry. So I say import pandas as pd. Okay, now import numpy as np. Okay, now the imputer class, that the imputer class imputes the missing values. So for that, we would import the imputer class from the sklearn module. So from sklearn dot pre-processing, okay, import imputer. Okay, great. So we would first run it. It's taking a bit of time. Okay, great. Now I would simply import the data set. Usually data set is in form of CSV file. So okay, our data frame is pd.read CSV is the function. Now I would just simply copy the address for that. So this read CSV function imports a CSV file, converts it into a data frame, and stores it in the df. Okay, so great. Now there's one thing to note. If you are a Mac user, then you don't actually need this double slash. You can simply use a single slash, but in Windows especially, this second slash is nothing but an escape character. You usually use in C or C++ or Java, that to print the special characters, you need this escape character. So that's simply that. But if you're a Mac user, then you don't actually need that. Okay, so after importing it, let's run it, and now let's look at the data frame. Okay, here is the data frame. We have 3 columns: country, age, salary, and we have a column named purchase. Now, what actually a machine learning model would do is, it would take care of these 3 columns. It would analyze this, and from these 3 columns, it would predict the purchased column. So if there are 10 if there are 10 variables in it, if there are 10 rows or entries in it, then what it would do is, it would analyze, it would observe the pattern from these 3 columns, and then look at that. If France, age, and salary are this particular readings, then what is the answer of the this purchased value? And after being trained, after that, it would predict the input value. So after giving these three columns and this 4th column as an input, it would get trained, and after, for any particular input, it would predict that whether it is to be purchased or not. So this purchase part is to be predicted. So this is called a dependent variable. So it is dependent on this three columns, and these three columns are called independent variables. Okay, so great. So now what we would do is we would actually store these three columns in a particular variable and this column in a different variable. Okay, so for that we have, let's say, x equal to df dot ilog. Okay, ilog. Now if for those who don't know ilog, I would explain it. Okay, ilog colon. Now we need these three columns. So what we would do is we would just write colon and then we write here 3. Okay, so now what this means, ilog is usually a slicing method for we won't say method because method is generally a parenthesis, but we would say the way the data frame are used for slicing. Okay, so df.ilog, now I means integer, so we would use integer variables, integer inputs, to be more precise, for slicing this particular df. Now what this means, this particular field before the comma is for rows, and this particular field after comma is for columns. Now if you have done slicing in NumPy, then you would know that what this colon means. It means we are selecting all of it. So if we are selecting all of the rows before the comma, then we would simply write just a colon. And for selecting the first three columns, then we would write for selecting country, age and salary, then we would write colon and 3. Now in range function you must have observed of range 0 comma 3, then it only goes up to 2. So that's say same thing here. We are starting from the first column and we are going up to second column, so we need to write here 3. Now we would be using it as an array, so we would write values. This is a data frame, and dot values would convert it in a NumPy array and would store it in the y variable. Okay, now same for y is equal to df dot ilog. Then we are using all the rows, so this comma -1. Okay, so dot values. So you can even use -1 here. You can simply write -1, even that is okay, or simply 3, even that is fine. Now what is -1 is, in slicing, if you are giving the positive values, then it starts from here, but if you are giving minus, then it starts from the back end. Now now if you are starting from the front end, then it would start from 0, but if you are starting from the back end, then it would start from -1. So -1, then -2, then -3, similarly. Okay, so dot values again. Now let's check our x and y. Okay, x. Okay, x is no. Okay, sorry, I forgot to run this. Then run this. Great. We have the x and we have the y. Here is the y. Good. Now as you have observed that there is an NaN value, and that's what our tutorial is for. We have to replace this NaN value. Now there are few strategies to replace this value. The most basic strategy is to replace this value from the mean of the values of that particular column. So if we want to replace this, then we would actually use this particular entries in that particular column. We would take the mean of it and we would simply replace by it. Okay, so first of all, let's import the class. Sorry, we have already imported it, so let's use it. We would have the variable as imputer missing values equal to NaN. I'm explaining it in a moment. Okay, so missing values is NaN. Now strategy equal to main. Okay, now what does this mean? Missing value means we are looking for NaN. We want to replace this NaN, and strategy means how you want to replace that particular value. So this is for what you want to replace, and this is for how you want to replace. And if you want to really analyze that, then you can just simply anywhere in the parentheses and simply press shift tab. It would give the whole description of that particular function or any class, or to be more precise, the parameters. Okay, now imp, now I'm going to use another variable imp1 equal to imp dot fit. Now what does fit mean? Fit means we actually want to fit the two columns which are supposed to be replaced into the imp class. So the imp class is here in the imp variable, and we want to fit it. We actually want to make the class know that these are the two columns I want to replace. So I would simply write x. Now the two columns which have the nan value are in the second and the third column. So we are selecting all the rows second. So so the index of that is 0, 1. So this is 0, this is 1, this is 2. So 1 and all the columns after 1. That's it. Great. Now we want to transform it. This is just a fit method. The fit method means that we make the class know that these are the two columns. So the fitting part is done. Now we want to transform it in the two columns where these two particular values are replaced by the mean of those columns, the values in that columns. Okay, so we would write imp1 dot transform. Now what you want to transform? The two columns. Okay, done. Now this would transform the two columns, but we want to store them. And where you want to store them? Again, those two columns itself. So we are transforming these two columns and we are overwriting it in those two columns as well. So I would simply write x of 1. Okay, so we are transforming it and we are storing it in those two particular columns itself. Okay, so great, there was no error. Now I am just deleting this particular tab. Okay, now let's look at the x. Great. Okay, congratulations, your first data pre-processing part is done. You have replaced those nan values by the mean of those particular values in that particular column. Okay, so that's it. If you observe, then if you actually manually do this particular thing manually, then it would take a long time. In professional world there are big chunks of data and you cannot actually do them by your own. So you can simply import the Imputer class, use it, and have your work done. Okay, so this was the first part of the data pre-processing, that was imputing, and now there are a few parts left. Let me write those few parts. The first part was imputer, second is label encoder. Okay, the third part is one hot encoder, which is nothing but the extended version of the label encoder. Okay, so the fourth part is splitting the data, and the fifth part is feature scaling. So I'm uploading this first part of the video of data pre-processing, and if I haven't uploaded this rest of the parts, then wait for a moment, I would upload it soon. Okay, so thank you, and don't forget to subscribe.